the Aligned Energy Foundation and in partnership with the Madison Astronomical Society and UW Space Place. And with that, I'll hand it over to Jim and his team.
Been talking. Can you hear me now?
I can hear you now.
Okay, sorry about that. Right, we're up here at Washburn Observatory on the University of Wisconsin-Madison campus, and I'm here with Jacqui and Ben, as you mentioned earlier, both of whom are astronomy majors, astrophysics majors, really, at the here at the university. And we're up here at the observatory, which is a pretty old operation, and it can take a lot of hands to operate this. So we want to give you a little glimpse. We would be observing from here tonight, of course, if it weren't for the weather, but we want to show you around the observatory a little bit and how we do things up here when we're open to the public. And if I don't say anything else, I should say that the Washburn Observatory has been open to the public on a regular basis since 1881. And that the regular pattern has always been that we're open to the public if the sky is clear on the first and third Wednesday nights of each month, and in the summer months every Wednesday night if the sky is clear. Of course, we're not doing that this year for obvious reasons, but that will be we'll go back to that pattern, I'm sure, as soon as we can do that. So what you see there, this is the Washburn telescope, the refractor that was installed here in January of 1879 is when this telescope became operational here in this room at the Washburn Observatory. And the telescope itself is well, for modern purposes, it's basically obsolete, but it was designed for a period in astronomy when research was actually done looking through the telescope. And these days on modern telescopes, people rarely actually look through the telescope itself. And there are instruments that are gathering the light or whatever is the research going on. But this telescope was designed for humans to look through it. And that's what astronomers did. And that's why it's such a great telescope to continue to use for the public. So let's take a quick look at how it works. I'm going to ask Jacqui to go over to the telescope, and we'll tip the camera down just a little bit here. So she's gonna tip the telescope up. You move the telescope manually. It's almost entirely manual, and she's swinging it now so that it's pointing south. It's pointing further south in the sky. And in fact, if we were going to be observing, say, Jupiter tonight, you can kind of see there. Jacqui, can you put your hand on the eyepiece there so that it's a little more clear where we would be looking right down there? In order to observe Jupiter, which is low on the horizon tonight, we'd have to point the telescope very low in the sky. But with a big long telescope like that, what that means is that the eyepiece gets very high, and so that's why we have a large set of stairs there that you can see. You can see her ascending to carry the eyepiece up, and careful up there, and you'd have to climb up those steps in order to reach the eyepiece in order to see Jupiter tonight. So that's swinging the telescope north and south, and we also have another axis we have to move it on, which is the east and west axis. And again, all of this is done manually, although there is perhaps you can see this crank, this wheel, looks like a ship's wheel right down here. Just sort of put your hand on that, Jacqui, so we can see that. There's that's for cranking the telescope long distances east or west up there. So this is all about moving the telescope. But suppose we actually did want to look out into the sky, we would have to open up the dome of the observatory. And in order to show you that, here we're going to just let me change the lights just a little bit. Flip the east and the west there. There we go. And turn that one off. Turn off the one on this side. There we go. So Ben has started the process here of opening the dome. Now we checked before, and it's not raining right now, or we wouldn't do this. This happens kind of slowly. but you can see, if you watch carefully, you'll begin to see a gap opening up there. That is the upper shutter separating from the lower shutter. Yeah, shine a flashlight up there. That's a great idea. So Ben's going to highlight that with a flashlight here. There you go. All right. So you can see the shutter opening up very slowly. The gap opens very slowly. It takes quite a while to get opened up here at Washburn, and we won't open up all the way. In fact, yeah, I think that's enough right now. In order to see the say Jupiter or something, we have to then also open up the lower shutter. One of you want to open the lower shutter? This I like to there we go. So that was, I like to say, 1882 technology at work there with the opening up the lower shutter, which works entirely by a rope and pulley system. So there we are. We've opened enough of the dome to observe if we actually wanted to now. But in order to say point towards Jupiter, we would need to rotate the dome a bit, or any particular object. We need to rotate the dome, and in fact, the dome will rotate 360 degrees all the way around. So if one of you would start the dome rotating, come this way, right? So you can see the dome, which rests on an iron track and wheels that look like small railroad train wheels all the way around. The dome will work its way around, and we could go all the way around. That's enough, I think, to get the idea. Let's just stop that there. So we would rotate the dome until we have a clear shot that we could point the telescope at whatever it might be in the sky that we're looking for. And then we could engage another piece of 1882 technology, which is called the clock drive. I'm going to see if I can move the camera here so that we can see the clock drive running. So I'm going to, one of you open up that door there. There we go. So you can see inside the pier of the telescope. Yeah, go ahead and aim a flashlight in there. You can see the mechanism. You can see the clock drive running inside there. And after we've pointed the telescope at an object and then engaged this drive, then it will move the telescope at the same speed that the Earth rotates, so that as Jupiter crosses the sky westward and ultimately will set on the western horizon, the telescope, once pointed at Jupiter, will keep up with it, so that we don't have to be constantly readjusting the aim of the telescope. Okay, that's good. Let's move this back. So that's a brief introduction to the mechanics of the telescope itself. There are actually two telescopes, and I keep talking about if we wanted to find Jupiter. Well, if we wanted to find Jupiter, it's difficult to find an object in the main field of the telescope because there's so much magnification, because we see such a small part of the sky. And so there's a finder telescope on here. And so Jacqui is putting her hand on it right over there. Ben's illuminating it. This finder telescope has a much wider field of view. Like the main telescope, it's actually it's the same age as the main telescope. It's 140 years old. Both of these telescopes were made by the famous telescope maker Alvin Clark and Sons from Massachusetts. And Alvin Clark and Sons made many of the most famous refracting telescopes that form their image collect the light and form the image with a large lens at the front of the telescope. Clark made many of the largest telescopes in the United States and some of the biggest in the world, including not far from us, Yerkes Observatory in Williams Bay, Wisconsin, has a refracting telescope that is like ours, except that it's about 2.5 times bigger, and that is the world's largest refracting telescope there at Yerkes. And the Clarks made that a few years, about 15 years after they made our telescope. Our telescope has a lens at the front there, the lens that collects the light and forms the image, that is 15.5 inches in diameter. And it's covered by a lens cap. I don't know if you're going to be able to see this because it's pretty high up there, but let me zoom in a little bit. Jacqui is going to open the, I'm zoomed in as much as I can. Jackie's going to open the lens cap there. Yeah, there we go. And Ben's got the flashlight on it. That lens up there, 15.5 inch lens, is the, at the time that it was installed here in the observatory in January of 1879, was the third largest in the United States. The second largest was an 18-inch telescope, which is at the Dearborn Observatory now in Chicago. And the largest in the world then, in 1879, was the Naval Observatory Telescope, where they have a telescope that's still there, which was a Clark telescope that has a lens 26 inches in diameter. And both of those telescopes, all of these telescopes, have now been dwarfed by the much bigger Clark refractors at Lick Observatory and at Yerkes Observatory right here in Wisconsin. So once upon a time, this was the third largest research telescope in the United States and the fourth largest in the world. So it was a pretty considerable instrument at the time it was installed here. And it was used for research right up until the 1950s, when the university built a new observatory. So right now, you're actually kind of lucky. I'm going to hold the mic over towards the pier of the telescope, and maybe you can hear this kind of ticking, whirring sort of noise. I hope you can hear that. That is the mechanism that winds the weights. The clock drive that we were talking about is driven by a very heavy iron weight concealed in the pier of the telescope. And when that reaches the bottom, in the old days, you'd have to crank that weight back up by hand. But now there's a motor that does that work for us, and so it's cranking the weight back up, and that will run the clock drive then without electricity or anything else for a few hours of observing.
Jim, yes, I think we lost the video from your feed. I see a message. Preview is currently disabled.
Lost
Enable
somebody
preview.
says they lost the video. Sorry, let's see if I can fix that. Okay, there we go. I hope that should be working again.
Yep, we can see it.
Okay. Yeah, there we go. Yeah, sorry about that. Camera turned itself off.
It happened. Oh, there we go.
So,
sorry.
Very often somebody will ask when they're looking through the telescope at Jupiter or whatever they happen to be looking at, how much magnification can the telescope provide? And an instrument like this can actually provide quite a lot of magnification, although we don't usually use it at extremely high powers. If we select a typical eyepiece from our box when we're looking at Jupiter, we might be magnifying about 150 or something like that, which is fairly modest with an instrument like this. But when they were doing research with this instrument, an awful lot of the research, for example, was measuring the separation between closely spaced double stars. For decades, this telescope was a very productive research instrument, and an awful lot of the observational data that came out of it didn't look anything like images of planets or galaxies or spectra or anything like that. It was numbers that indicated the changing separations of binary stars, of pairs of stars orbiting around each other. And for that kind of work, the astronomers might use very high magnifications in the hundreds of times, much more than we would typically use today for viewing of planets or the moon or something. So if we
We lost
let's see.
video again.
If we have a sorry, I was just over there to check and see if we have any questions. We were looking at the telescope, and I talked about the mounting and how the
Pardon me, Jim.
telescope moves very briefly, but
Pardon me, Jim. Yes, we lost
yeah.
the video again. Oh, it's back. Sorry to
I'm sorry?
interrupt you. Sorry to interrupt you. The video is back now. And we don't have any questions currently.
Okay, but you're seeing the video okay?
Yes, we are.
Yeah, I thought so. Okay. The mounting of the telescope that where we demonstrated the telescope's motions, that mounting is actually fairly new technology compared to the telescope itself. So the light blue part of the telescope is original from the way it came from Alvin Clark in 1879. But the darker blue part that Ben has the light on right now, and the pier that mounting sits on, that's actually a new mounting and pier that was installed in here in the early 1930s. And it was a big improvement over the original one that was driven in part by the kind of research that the astronomers here at Washburn Observatory were doing in those days. They were developing a new technique called photoelectric photometry, which photometry basically means quantitative measuring of the light, of the brightness of celestial objects, usually stars. And so they needed an improved mounting for that kind of research. And so the old mounting was removed in about 1933, and this new mounting that we see now was actually built here on the university campus in the university shops, and then installed over here because a commercial mounting would have cost about 3 times as much, but there were talented machinists here at the university who could do that same work. So this is a homegrown, home designed and home built telescope mounting that's been here since the early 1930s and continues to serve pretty well today, although it certainly doesn't meet modern standards of guiding accuracy and that sort of thing. Okay, so if we were observing here at night, we
Jim,
would typically
we've
have the
lost the
lights
video
off.
again.
Of course, we have the lights on right now so that you can see things here in the
Jim,
we've
we've lost the video again.
In the dome.
Thank
And
you.
in order to find things in the sky, it can be really difficult from inside here in the dome because you don't get to see very much sky. We see only a little chunk of sky looking out our dome window. And so there's if any of you visited the observatory before, you may have seen that there's a door that goes out onto a balcony right there. We can't take you out there on the balcony right now because my camera won't extend that far out. But when you come here to the observatory, visitors like to step out on the balcony because it has a nice view out over the lake. But more importantly, it gives you a full view of the sky, and so you can get oriented when finding things with the telescope, you can get oriented and figure out where to look for something in the sky before you try locating the dome in the right place and locating the telescope into the right part of the sky. Okay. Oh, I see. We were losing video when I would switch to the other screen. Okay. Okay. Well, I'll wrap up here. We only have a couple of minutes, sorry. Well, okay, sure. Ben suggests talking about what we look at on a public night. It varies quite a lot, of course, with the season, because not everything is available at any given time. We're right here in the middle of the city, so unlike in 1879, we don't have a nice dark sky for observing the way they used to. And so we tend to look at bright objects. Planets are great, of course, and so are things like double stars and star clusters. We can't really do very well with such things as galaxies or diffuse nebulas or things along that line, largely because of the urban light pollution. Also, this telescope was not really designed for those sorts of things. It was really designed for an era in the history of astronomy when astronomers were interested in things like stars and measuring, for example, the spacings of double stars, but also planetary observing, and that was done a lot here. So when you come here to Washburn Observatory, what you're likely to view is whatever planets are available in the sky, and then perhaps other objects that are visible at the time, bright double stars, maybe a planetary nebula or two, things that will show up here in the light polluted sky.
Jim, we have a good question in the Q&A.
We do have a nice sky, relatively sky off to the north. Sorry?
Yeah, we have a good question in the Q&A.
Okay.
Question is the observatory open during COVID on public nights?
Right, are the public nights going during COVID? No, I'm afraid not.
Okay.
We are closed down until the university reopens for public events. So no. The way to watch for that is to look for announcements on the Washburn Observatory webpage, which is not too hard to find. We have a short URL, which is go.wisc.edu/washobs, WASHOBS. So go.wisc.washobs. If you point your web browser to that URL, there will, when we reopen, there will be announcements there that we're resuming the public nights. So regrettably, no, we have no public nights during COVID.
Thanks, Jim.
Got any other questions here? Okay, well, I think we'll wrap up from here, Misty, unless there's something else.
Oh, there's one more question, Jim. Yeah, Teresa would like to know if there was any research being conducted at that observatory now.
Is there any research being conducted at this observatory now? That's a good question. No, is the answer. This telescope hasn't been used for research since 1958. And the reason for that is that 1958 is when the university built and opened a new observatory west of Madison called Pine Bluff Observatory. So that was out in the country and had a bigger telescope, and research moved from here. And since 1958, the telescope, and the Washburn telescope, has been used only for educational purposes. We bring our astronomy classes here, and also for the general public. So that's been its only goal, primarily as a historically preserved antique telescope that serves the public and the educational missions at the university. The research that most observing astronomers do these days is with much bigger telescopes located pretty much anywhere aside from Wisconsin. Somewhere, generally preferring mountaintops where the sky is clear for as much of the year as possible. So we have astronomers working in the Andes and in Arizona and New Mexico and in South Africa and many places like that, but none here. Sorry. Hawaii. I forgot Hawaii. Quite right.
Hannah has another question. The telescope in Pine Bluff, is the general public able to go visit that telescope?
No, the question is the Pine Bluff telescope open to the public? Only on very special occasions do we open up Pine Bluff. It has happened in the past that we open up, say, for the Perseid meteor shower and invite the public out for that. But the telescopes at Pine Bluff are not set up for viewing. In fact, the largest telescope, the 36-inch there, doesn't even have an eyepiece. It was designed to have either a spectrometer or a photometer attached to the telescope. So it's really a product of that change that I mentioned earlier, that this telescope, the Washburn telescope, was designed for people to look through. But the Pine Bluff telescope was one of the early of the new breed of telescopes that were specifically designed for high efficiency with instruments, but not for people. So no, we never use those telescopes for just looking through with the human eye.